Welcome, folks. In this pre-work and in this sequence of pre-works, we're going to look at logarithms, and this will be our introduction to logarithms. And so to help us out with that, I want to recall some ways in which you learned facts back in your previous math career that might have been challenging at first, and you relied on some other fact to help you out. So let me explain what I mean here. So when you went to learn division, if somebody, before you knew what division was, when somebody tried to explain to you what is 30 divided by 2, you said that, and they said, explain why 30 divided by 2 is 15. The reason why was because there was an equivalent multiplication fact. And the equivalent multiplication fact was that 15 times 2 was equal to 30. And so when you were trying to learn division, what you did is you pulled upon your knowledge of a multiplication fact. Similarly, when you were learning square roots, when somebody tried to explain to you that the square root of 25 was equal to 5, when you were looking for some sort of explanation for it, the explanation that you gave was that because 5 squared was equal to 25. So this question we learned how to ask, what number when I square it gives me 25? And the answer was 5. Okay. But again, when you first learned square roots, those were difficult, and you had to rely on your knowledge of squaring expressions. When you were learning cube roots, that was similar. When you were first learning how to take the cube root of -8, for instance, and you said that that was equal to -2, the way you justified that was because if you took -2 and cubed it, you got -8. So we used our knowledge of other facts to help us learn these new operations. Similarly, if you've seen the inverse trig and trig expressions, you've learned how to say that the arc sine of -1/2 is equal to pi over 6, for instance. And the justification that you gave for this as you were learning how to work with your arc sine was because the sine of pi over 6 is equal to -1/2. So here we had, after you got comfortable with evaluating your unit circle trig values, you could then give inverse trig statements. Now I'm glossing over something on both specifically on both B and C here, or B and D here, that there's a domain issue that we have to be careful of in these two cases. So I just want to mention that for completion of these notes. But my point still stands that as you were trying to learn this new operation, the new operation of division, or the new operation of taking a square root, or taking a cube root, or taking the arc sine of something, you relied upon your knowledge of the inverse operation to help you out with that, the inverse operation that you were more familiar with. So now we're going to look at logarithms, and we want to go ahead and define what we mean by a logarithm base A. So we're going to define the logarithm base A. That's the word base. The logarithm base A, let me make sure that's legible there, logarithm base A, and we're going to define the log base A of a number m to be the number n if and only if a to the n is equal to m. And folks, I'm calling this the essential definition, and I can't overstate how important it is to know this definition. You cannot work with logarithms at all if you don't know this definition. So we're going to explore it through the rest of this pre-work, but if you don't have this down, you won't be successful with logarithms. That is the key to understanding logarithms. Okay, before we dive into an example, let's just make sure we've got the vocabulary correct, that we're using it correctly. So this expression that you see right here underlined, this expression that you see right here, we're going to read it as the logarithm base 2 of 32. So practicing reading that, this would be the log base 2 of 32, or the logarithm base 2 of 32. One thing I like to ask students when they're first learning this concept of a logarithm is, how much do you see when you look at this? How many components do you see when you read this expression here? And I have a lot of students sometimes mistakenly say they see 3 components. I only see 2 components. The 2 components that I see are log base 2 and the number 32. Those are the 2 components that I see there. The logarithm base 2 and the number 32. Just like if you look at, say, the cube root of 64, this really has two components. You've got the operation, the cube root, and then you've got what you're taking the cube root of. So I want you to think of log base 2 as something you do to a number, the same way the cube root symbol is something that you do to a number. And students, when they first learned this cube root, they might have thought there were three components there. They might have seen the number 3, the check mark, and the number 64. Likewise, I sometimes have students see the log, the base 2, and the 32, and they treat it as three components. And it's really important that you think of this base 2 as, in a sense, almost like it's attached to the logarithm. Okay? And that's just conceptually how we want to understand it. The same way you wouldn't think of the check mark on its own, because that would be a square root. We have the cube root, and it's all one entity when we write that out. So hopefully that does some clarification. Okay. So let me ask you, and I'll let you do this on your own. On your own, how would you read this expression right here? So pause the video, and I want you to write it out in words similar to what we did up here. Okay, so now that we've gotten the vocabulary down, now that we can read this, it says simplify the log base 2 of 32. Let's go ahead and do that. Well, it turns out that the log base 2 of 32 is equal to 5. Why? Well, on the one hand, that's just what it is. Just like if I asked you, what is 30 divided by 2? The answer is 15. Why? Well, that's just what it is. But oftentimes when we were trying to learn these new confusing operations, we put them in terms of older operations that we were more comfortable with. And we're going to do the same thing here using this key decoder right here. We say that the log base a of m is equal to n. That is the same as, notice that here's the base a. That letter a is the same as this a right here. So if I were to rewrite this logarithmic statement as its equivalent exponential statement, the equivalent exponential statement would be base 2. There's the 2. That's the base there. That's the base of the exponent. And then m is the entity that I'm taking the logarithm of. And that becomes what the entire exponent is set equal to. So that's going to be equal to 32 when we raise 2 to what power? And the answer is 5. So one thing that's really worth practicing, folks, is I've said this is the essential definition, and it really is for a little while just learning how to point at the pieces and do this interchange. And that's what you're going to practice through the remainder of this pre-work. I think when I read this question right here, what is the log base 2 of 32? The way I read the question, and a lot of folks do, is they ask themselves the question when they read this, 2 to what power equals 32? And that's the answer to your question. So when you read simplify log base a of m, you ask yourself a, because that's the base, a to what power equals m? So what I'd like you to do now is on your own, I want you to simplify the log base 2 of 64 and use 5 as a guide. Use number 4 here, number 3, where is it? It's up a little further. Use number 2 here, your definition. Use number 5 as a guide and practice phrasing it like I said in question 6. So pause the video and I'd like you to do number 7 on your own. So here's the solution, folks. I went ahead and gave it to you. The log base 2 of 64, so practice reading that. The log base 2 of 64 is equal to 6. And the justification that we give is its equivalent exponential statement. The equivalent exponential statement that we assume we're familiar with is that 2 when raised to the 6th power equals 64. Let's continue. Here we're asked to simplify the log base 32 of 2. So resist the temptation to go too quickly on this, folks. We want to know what the log base 2 of 32, excuse me, I just did it myself. Careful there. We want to know the log base 32 of 2. This asks us the question, the base would be 32 to what power equals 2? And the answer is 32 to the 1/5 power is equal to 2. And so what is the log base 32 of 2? That asks the question, 32 to what power returns a 2? That power is 1/5. So what I'd like you to do is I'd like you to try this one on your own. I won't give you the answer this time, but use number 8 as a guide, just lining things up. Really, all you're doing right now, if you're struggling with this, all you're doing right now is you're using this essential definition and you're lining the components up to the point where you get to an exponential statement that you're able to answer. So go ahead and pause the video and answer number 9. Okay, so hopefully folks, we're seeing that our ability to do logarithms just comes down to our ability to reason with our exponential facts. So just like you can't do division without knowing multiplication facts, you cannot at first do logarithms without knowing the equivalent exponent facts. Many teachers assume that you're comfortable with the following exponents, and I'm going to do the same. So these are all sort of fair game exponents to expect you to know at any point. So let's go ahead and fill in a couple blanks here. For example, 2 squared is equal to 4. Let's take a look here. 5 cubed. Well, let's see here. 5 cubed is equal to 5 times 5 times 5, which is equal to 25 times 5. That's 125. So 125. But what I want you to be able to know is I want you to know that 5 cubed is 125 without doing the justification that I just did here. So this is where I do recommend that you put these into a note card and that you have these down. It will be in your interest to know these facts going forward. Let's go ahead and put one other one. 7 to the 0th power is equal to 1. And let's see here, let's do this one. 4 to the 1st power is equal to 4. So I did a few of these tables for you, this table for you, but I'd like you to pause the video and complete the rest of this table. Okay, so now let's go ahead and continue. What I'm going to ask you to do is use the table above to help you answer some questions. For example, one of the problems that I did for you was I said that 5 to the 3rd was 125. So then when I ask you log base 5, 125, what you want to do is you want to interpret this as the question, 5 to what power is 125? And the answer to that is 3. This fact right here in part A is this identical fact right here that we listed in our table. Great. Okay, so let's see here. There's a couple more that I want to make sure you have in here to help you out. Here we have the logarithm base 7 of 1. That's asking the question, this one right here is asking the question, 7 to what power is 1? And the answer to that question is 7 to the 0th power is 1. And you see that that fact right there is equivalent to this fact right here. So those two facts go hand in hand. There's the exponential statement, there's the logarithmic statement saying the same thing. Finally, folks, I think we did 4 to the 1st power is equal to 4. So what is the log base 4 of 4? And the answer to that is 1. Why is that? Because this asks the question, 4 to what power is 4? Now careful here, when I say 4 to what power, the reason why I'm saying 4 to what power is because of that number 4 right there, and the reason why I'm saying 4 to what power is the number 4 is because of that number 4 right there. That's a little bit more clear in some of these other examples, such as this one here. Okay, so folks, this is going to be a little challenging if you haven't done this in a while. I'm asking you to fill out this table, but you've got everything that you need to do. The only exceptions are letter L and letter P, but again, I think that because of the way I've asked these questions, you should be able to find a pattern in there that will be helpful. So folks, I'm going to ask you to fill out that table, and then I'm asking you to do number 12 on your own. There's no video for number 12, but I'm just asking you to work through it and then answer the questions below. So I'll see you in the next video as we continue on with our introduction of logarithms.